So I greatly apologize for the technical difficulties, but here are 403 Ellipse Notes, take 2. And I wanted to start again by looking at the manipulatives. So the manipulatives show us the 4 types of conic sections. And so a conic section is really just the slice of a cone. So if I slice a cone parallel to its base, I get a perfect circle. And the definition for a circle is it's a set of points that are equidistant from a fixed point called the center. So we're going to be focusing on circles and ellipses. So an ellipse, here's my ellipse, is formed when you slice a cone diagonally. But you're slicing it diagonally and you may not intersect the base. So I'm slicing it diagonally and see how the cross section makes an ellipse. The ellipse definition we're going to learn today is a set of points, and the sum of the distances from 2 fixed points called foci is constant. That's a mouthful, but I will show you what that means. And then we talked about parabolas. We're going to just briefly see parabolas in relation to conics because we don't have much of a unit to spend on it, but you're cutting it diagonally parallel to one of the sides so that it goes right through the base, and there's your cross section of your parabola. And the fourth one is hyperbola. So for there to be a hyperbola, you actually need 2 inverted cones. So you would have 2 cones on top of each other like this. So when you slice the hyperbola, you're slicing it right down through the top of both of those. So you actually end up with a hyperbola going in this direction and this direction because you've sliced 2 cones all the way through. So a hyperbola looks kind of like 2 parabolas going in opposite directions. So today we're going to focus on the ellipse. So if you've already filled in your notes just from looking at the pictures, please follow through and try some of the problems because you could do them again on another sheet of paper. I apologize for the technical difficulties yesterday, but an ellipse is a set of points, the sum of whose distances from 2 fixed points called foci is constant. So we're going to unpack that as well as these definitions in a minute. So first, I want to do one of the problems on the next page because this kind of ties together what we did last class with completing the square. So we're going to complete the square the same way with an ellipse. So we're going to put together our x terms, 9x squared plus 90x. We're going to put together our y terms, 4y squared minus 16y, and then equals negative 205 on the other side. I can't complete this square. I could try dividing by 9 because I need to get x squared by itself, but if I divide by 9, many of these terms will not divide by 9. So I'm going to divide by 9 just on the first 2 terms. So that would leave me with 9x squared plus 10x, and I'm going to leave a space to complete the square in a minute. I'm going to do the same thing with my y terms by factoring out a 4. Y squared minus 4y, and then equals negative 205. And I should put a plus here because that was a positive 4. So now I can complete the square and complete the square. So the rule to complete the square is you cut the b value, in this case 10, in half. So 10 divided by 2 is 5. And then you square that half of the b value. So 5 squared is 25. I'm going to add 25. Now, do I add 25 to this side to balance the equation? Well, not quite, because there's a 9 here in front of the parentheses. So what I really just added to this side was 9 times 25. And 9 times 25 is 225. So I actually need to add 225 to both sides of the equation. Now I'm going to cut this b value in half, negative 2. Negative 2 squared is 4. So I'm going to add 4. But instead of just adding 4 on this side, I need to add 4 times 4, which is 16. So let's put this together now. So I have 9. This would factor into x plus 5 times x plus 5. So this is x plus 5 squared plus 4. This trinomial would factor into y minus 2 times y minus 2. So y minus 2 squared equals, I have negative 205 plus 225 plus 16 is 36. This is where we would have stopped with our circle, but if you notice, an ellipse doesn't have a radius. It has these kind of coefficients here. So your last step for finding the equation of an ellipse is going to be to divide through to get 1 on this side of the equation. And that tells you that you can read the other side of the equation. 9/36 is just 1/4, right? So I really have x plus 5 over 4. And 4/36 is really 1/9. So I have y minus 2 squared over 9. Here is my conics equation. So this was a lot of completing the square work, which is one type of skill. Now I'm going to read this conic equation, which is another type of skill. You read the center of the ellipse just like you read the center of a circle. Left 5, up 2. 1, 2, 3, 4, 5, and up 2. There's the center of my ellipse. So now, horizontally, this is kind of my radius squared horizontally. This is actually called the b squared value. So b is 2, because I'm going to take the square root. This, the bigger number, is 9, so that's considered the a squared value, which tells me that in this ellipse, a is 3. So now ellipses can either be horizontal or vertically oriented. When the a value is underneath the y, it's going to be a vertical ellipse, because from the center, this tells me it's under the y value, go up and down 3. 1, 2, 3, plot a vertex, 1, 2, 3, plot a vertex. This tells me that in the x direction, I need to go left or right 2. 1, 2, 1, 2. So here is my ellipse. So we're going to summarize what we just did on the front page in a minute. Let's do one more example kind of like that. So let's practice completing the square, or you could pause the video and try completing the square on your own if you want. So we've got 16x squared, we've got our y terms, and we moved that to the other side. So here, I actually need to I don't need to do anything to 16x squared, first of all. This I need to factor out at 25. So I have y squared, 300 divided by 25 is 12. So minus 12y. I need to complete the square by cutting this value in half, -6, and then -6 squared is 36, so plus 36. How much do I need to add to the other side? I need to add 25 times 36, which is 900. So I'm going to add 900 to the other side of the equation. So I have 16x squared plus 25. This would be y minus 6 times y minus 6, or y minus 6 squared, equals 400. And then your last step is to divide through by 400 to get 1 on that side. And what does 16 over 400 reduce to? Whoops, 25. X squared over 25 plus, so 400 divided by 25 is 16. Y minus 6 squared over 16 equals 1. So the 1 over here tells me that I'm ready to read this side of the equation. So the center of my ellipse is at 0, comma, up 6. 6. So this time, the bigger value, a squared, is under the x, and the smaller value, which we called b squared, is under the y. So that tells me that a is 5 and b is 4. This is going to be a horizontal ellipse, because from the center, in either direction, I need to plot 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then in either direction, up and down, I'm going to plot 4, because the 4 is under the y value. 1, 2, 3, 4. 1, 2, 3, 4. So here is my ellipse. Compare the shapes of these. So next time we're going to talk about eccentricity and how eccentricity compares how elliptical or circular an ellipse is. So we are going to get to that. All right, I'm going to jump back to the front page now and define some things for you. So I bet now that we've done a couple problems, you probably can figure out what some of these things mean. Okay, so the major axis is the longer axis, and its length is 2a, because from the center we go A in both directions. The minor axis is just the shorter axis, and it has length of 2b, because we go B in either direction. Could be vertical or horizontal, could be vertical or horizontal, wherever the bigger value is, under the X or under the Y. The foci are the fixed points. After we do this front side, I'm going to go back and show you where to put your foci. The vertices are the end points of the major and minor axes. The center is at H, K. And it's also it is the intersection of the major and minor axis. All right, so relationship between A, B, and C. We've talked about A and B, so what is C? I want to draw this ellipse for you. So this happens to be a horizontal ellipse. Here's my center. And didn't we go over this far A, and we went up B and down B? All right, so the two foci are located C units from the center of the ellipse. So if we need to know how far the foci are, we need this relationship between A, B, and C. The relationship is that A squared equals B squared plus C squared. So it's a Pythagorean identity. You could just memorize it, and then we're going to use it, but I want to show you where this comes from. All right, so when you form an ellipse, the definition of an ellipse is that it is the sum. All right, so here's the sum. If I add this distance plus this distance, that is a fixed distance. As I drag this string around the whole ellipse, I generate all these points. So I want to show you a quick video of someone generating all the points of an ellipse. All right, so I hope that you can see this. So I'm going to play you this quick video. So you can see on here that this is the string that's the fixed distance. And here is your fixed point, and here is your fixed point, right? And the center of the ellipse would be right here. It's not marked. So watch what happens when this person stretches the string out. The string never changes in length. So the string is considered the sum from these two fixed points is always constant. And you can see that as the person draws it around, it is forming a perfect ellipse on the paper. And now they're building something. Okay. So I want you to know like what the string is that I'm referring to. So this distance plus this distance is always constant. So I want to use this as the same ellipse that I just drew, but what happens to the string when I stretch it all the way over here? Because I can generate any point on the ellipse. So what if I generate this point? So I still have my string that's red, and I'm stretching it all the way over here. It's really on top of each other, but I want you to see the two pieces of the red string. How long is the string? So the string, if I just cut this little piece off and I reinserted it over here, doesn't the string have to have the length of the major axis, right? Because it's this long piece plus that little like hash mark piece. So the string's length is always 2a. All right, I want to draw one more ellipse for you. Let's look at our ellipse when we generate this specific location. Same foci, same red string, right? So all these points are generated by the same red string being dragged around. Well, if the string is 2a, and this is now an isosceles triangle, don't those two red strings have to each be equal? So they're both 1a. Isn't this the distance c that we're trying to find, center to focus? Isn't this half the minor axis? So that's b. Do you see how I just formed the Pythagorean identity for the Pythagorean theorem? A squared is the hypotenuse, and that has to be equal to b squared plus c squared. So we usually refer to the hypotenuse as c squared, but we could also say leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. So this is our Pythagorean identity to find c on an ellipse. All right, so here are the two forms that you're going to see. If it's horizontal major axis, it's this type of ellipse. A vertical major axis is this type of ellipse. X minus h squared, y minus k squared equals 1. That stays the same for both. X minus h squared plus y minus k squared equals 1. Stays the same. So the only difference is where your a squared and b squared values are. If it's horizontal, a squared is paired with x to go left and right. If it's vertical, a squared is paired with y so that the longer axis goes up and down. And it says, notice both forms have to be set equal to 1. So we've already done two examples on the next page, but let's go and find their foci. So we just said to find the foci, we need to solve the equation a squared equals b squared plus c squared. I know from the equation that a squared is 9. I know from the equation that b squared is 4. I need to solve this for c squared. Subtract 4 to the other side. So c squared has to be 5. So c is the square root of 5. I think that is 2.2. Square root of 5 is 2.2. So I'm going to go 1, 2 away from the center and put a dot on the major axis to show where the foci would have been placed. 2.2 away from the center. And we're going to need to know how to do this for eccentricity next class. Okay, so now I'm going to do the same thing. A squared equals b squared plus c squared. A squared in this case is 25, and b squared in this case is 16. So c would have to be 3, right? This is a Pythagorean triple. If c squared is 9, then c has to be 3. This was a horizontal ellipse, so I need to go 3 on the horizontal axis. The foci always lie on the major axis. So you, in a minute, are going to take what you just did on here and try it 3 times on your own. But before you do that page, I want to walk you through these 3 types of examples where you have to find an equation. It says, write an equation given the following information. So let's work through how to write some equations. The center is at 0, 0. So that's a big help. I know that it's just going to be x squared plus y squared equals 1. I don't have to worry about h and k. I need to fill in a squared and b squared in the equation. One of the foci is at 3, 0. 1, 2, 3, 0. That tells me that this must be the major axis, right? And c is 3. So a squared is going to go under x squared in a minute because this is the major axis. Oh, and it tells me the major axis has a length of 10. So that tells me that this is 5 and this is 5, so that the whole length of the major axis is 10. If a is 5, then a squared has to be 25. So all I have left to solve for is b squared. A squared equals b squared plus c squared, the Pythagorean identity. So a squared is 25. We don't know b squared. And c squared is 9, right? 3 squared. So b squared has to be 16 again, our Pythagorean identity, right? 16 plus 9 is 25. So our final equation would have to be that. All right, let's take a look at a different combination of information. So this time, hey, great, our center again is at 0, 0. X squared plus y squared equals 1. All I have to do is figure out a squared and b squared. One of my vertices is at 0, -3. It doesn't tell me if that's major or minor. All right, the semi-minor, so half of the minor axis has length of 2. That must be my b value, right? Half of the minor axis. The minor axis is 2b, so half of it is b. b is 2. This is 3, so that tells me that the 2 must go in the other direction, and there's my ellipse. So this is a vertical ellipse. The a value is 3. A squared must be 9. The b value is 2. B squared must be 4. There's my equation. The last question. The center is now at 3, 5. So 3, 1, 2, 3, 4, 5. There's my center. I'm going to set up my equation first. X minus 3 squared, y minus 5 squared equals 1. Write 3 up 5. I need to figure out my a and b values. Do you know what the word tangent means? Tangent means it touches it at one point, and that's it. So actually, this ellipse looks like this, if I were going to draw it. Well, that kind of gives you your a and your b value, right? Your a value must be 5, and your b value must be 3. Vertical of 5 goes under the y, horizontal of 3 goes under the x, a squared, b squared. So I apologize this was not available yesterday. Now you are going to do examples 1, 2, and 3 on this last page and submit them to Google Classroom. Thank you.